This way to use units here, $140 to dig. Is that okay?
Yes.
All right, so the next one here, there's kind of this fill in the blank again. So in terms of like what goes where, 5 means C prime of 20 equals 5 means that when the hole is, and this is same thing as before, deep, 20 feet deep, the cost of digging is a rate of 5. Now the units are very important here. The units of the derivative is always y over x units.
Mm-hmm.
So that would be feet per dollar or I'm sorry, dollars per foot. But it's always a rate.
Oh, wait, so is this one not even solving?
You're just writing out, you're interpreting. You will see a question on the multiple choice that's like that, where they ask you to do an interpret situation.
Okay.
All right, so the thing with the rate, it's always in units of y over x. All right, next question here. Particle moves back and forth on a horizontal track for 0 less than or equal to t less than or equal to pi over 2 minutes. The particle's position in feet is given by the function s of t equals 1/2 tangent t. Find the acceleration of the particle. Oops, sorry, I didn't mean to move that. At t equals pi over 6 seconds. So acceleration is the second derivative. It's s double prime of t. Could you tell us, calculate the first derivative of this, please?
Yeah, just 1 second. I'm finishing copying up the other one.
Oh, sorry about that.
That's fine. I have it like mainly done. Okay, so find the first derivative of which one? S of t?
Yes. You're welcome to look at a reference sheet if you need. For this one, we need the first derivative of the position function. What's the derivative of tangent?
Secant squared
Good. So the whole derivative, though, with the 1/2.
would be 1/2 secant squared, right?
Perfect. But this one's asking for the acceleration, which means the second derivative, which means you have to find the derivative of 1/2 secant squared.
Doesn't okay. Wait.
So this one's kind of on your derivative table, kind of. It might help to look at it this way: 1/2 secant of t to the power of 2.
Well, I don't remember what secant of t was.
Okay, well, but before you do that, though, you have to take the derivative of the outside function, this exponent. So 1/2 times 2, keep the inside function, go to a power of 1 instead of 2 for the exponent, and then you're going to multiply by the derivative of secant. What's the derivative of secant?
I don't remember.
All right, let me get you a derivative table here. So this is like a good use of your time, is to get a derivative or integral table really well down, memorized, things like that. So this one I like. I think this one I like. Let me see here. Yeah, this is a good one. All right, so let me drop this in the chat here. Really important that you know these derivatives and integrals. This one's going to be under the trig section there. What's the derivative of secant?
Secant tangent, secant x, tangent x.
Yeah, secant t, tangent t. Now you don't need to simplify because you're evaluating it. That's up to you. Is this like, to me, this is not a calculator problem, but is your teacher allowing you to use calculator on this?
I don't know, to be completely honest with
Okay,
you.
so it's up to you here. I mean, you can go secant squared pi over 6 in your calculator, tangent pi over 6, or you can do it by hand.
Okay.
Some students, it's like there's so much here, it's very frustrating. So here's a reference sheet to Trigger reference sheet for your unit circle in case you need a reminder on that. So secant is 1 over cosine squared pi over 6. Tangent is sine pi over 6 over cosine pi over 6. So in your unit circle there, cosine pi over 6 is the x value, so square root of 3 over 2, so it's 1 over square root of 3 over 2 squared times sine pi over 6 is the y value, 1/2 over square root of 3 over 2. Does this all look familiar?
Yeah.
Okay. All right, so the one on the left here becomes 1 over 3 over 4, which becomes 4/3 because you flip with the 1 over. One on the right, the becomes 1 over square root of 3, which is really square root of 3 over 3, and that helps you when you're simplifying a little bit, I guess. Depends how the answer is supposed to be. But this becomes 4 square root 3 over 9.
Okay.
It also wants the units. So that's where you got to go back to the original, part of the problem. It's like, all right, what's the position? The position in feet. The time unit is minutes. So the first derivative is per minute. The second derivative is per minute squared. Acceleration is always something per something squared.
Okay, yeah, that makes sense. Okay. 4.3.
Yep. All right. So to answer 4.3, if you don't know the answer by just looking at it, and I'm not sure that you would know by just looking at it, you would have to find the antiderivative of each of these and decide which one is correct. So like this first one here is the integral dp equals the integral 200 dt. These are what are called separable differential equations, so that you split apart the dp dt. The dt goes to the right, the dp stays on the left. Do you remember the integral of dp?
Wouldn't it just be like P or
Yep,
T?
just p. How about the one on, the one on the right, the integral of 200
Two-
dt?
Like 200 P or D 200 T?
T, because the variable is t. So is this exponential?
No.
It is not. This is linear though. This describes linear growth in the size of the population. So that's I guess that first one. Then we'd say, okay, that's linear. Yay. All right. Now we got to do the same thing for the second one. Integral dp equals integral 200 t dt. So p on the left. This time though, it's the power rule for integrals. What does that become?
200 T squared over 2. So it'd be 100 T squared.
Perfect. And that is not linear, not exponential. It's quadratic. Okay, so we keep going here. Next one is the integral dp equals integral 100 t squared. This becomes p equals 100 over 3 t cubed. It's cubic. Okay. So not exponential, so it's got to be over here. This is where it gets a little bit different. This time the variable p is on the right, so it actually moves to the left. Like you divide both sides by p, and you get dp over p integral equals integral 200 dt. That's the whole separable differential equation. So that's where the left side's now a little bit harder. Do you remember the antiderivative of 1 over p?
ln.
ln. So this is natural log absolute value of p equals 200t. What do you do to undo the ln? How do you
You
solve for?
like make it to an E.
That's right. Now we're onto the right track here. P equals e to the 200t. This is our exponential. Just for getting through everything, just as a reminder here, the one on the left here becomes 1 over p squared dp equals integral 100 dt. 1 over p squared is minus 1 over p equals 100t. And to solve for p, it's minus 1 over 100t. This is a rational, in case you see something like that.
Okay.
Any questions on that?
No.
All right. Does this all look familiar? I mean, did you guys do a
Yeah.
unit on population growth?
Like a day.
A day, okay. I mean, you see this again in differential equations, which is after calculus 2 and after calculus 3. So it's kind of down the road, but it does come up again. All right, determine dz dt if you know that z equals xy squared. They give you a z value, give you a y value, give you a dx dt and dy dt. This could feel a little overwhelming, but what they're saying is that x is really a function of t, and y is also a function of t. This right here, when you see two variables, you want to think implicit derivatives.
Okay.
Do you remember how to find the derivative of this using product rule, but it's an implicit derivative situation?
Wait.
I'm sorry, did you say you are familiar or not?
Yeah, I am. Okay.
Okay. Do you want to try this one here, at least calculate a derivative?
Okay, so I calculated the derivative, and then should I just plug in numbers?
Well, let me verify your derivative. Your derivative should be 1y squared plus, okay, so that's the derivative of the first, keep the
But do
second.
we keep x,
So
the derivative of x?
yeah, the derivative of x is 1. You keep the y squared.
Okay.
All right. Now, because it's product rule, you now have to keep the first x. The derivative of y squared is 2y, but this is where you need your chain rule here. And I guess we have to do it with this one too. So I'm going to back up here, dy dx. So the derivative of x is 1, but then you also have to multiply by the derivative of dx dt here. That's why they're giving you this dx dt, dy dt stuff. So yeah, the derivative of x is 1. It's 1 dx dt. And then dy of y squared is 2y dy dt.
Okay.
Okay, so here's what we need. We need dx dt. Do we have that?
Yeah.
Yeah. Do we have y? 1/2. Do we have x?
Yeah. No.
No x. All right, so that's a problem. But we have z equals xy squared. And we know that z is 3 and y is 1/2. So we can calculate x. What would X be in that situation?
12.
12, good. 2 times y is 1/2, and then dy dt is, or t, not x, is 5.
Okay. And then to solve.
Just, yeah, you're just combining like terms here. So this is -2 times 1/4. So that's -1/2. You got 24 half, that's 6 plus 30. And there's you can add those up, get your final answer.
So. Wait, how'd you get 30?
12 times 2 is 24. Okay, sorry, I got the wrong number there. 12 times 2 is 24. Cut that in half. That's 12 times 5 is 60. Thank you.
So
Good
it's
catch on that.
55.5
Yeah, 59.5.
or 59.5, yeah.
So the main thing here is, I guess, a reminder of your implicit derivatives, if you haven't done those in a while. 4.6. Okay. Let me know we can move on to 4.6. 4.5 is a free response question that's not on here.
Okay. Okay. So the 4.6.
Yeah. Given g of x is a differentiable function about which little else is known other than g of -3 equals 2. So notice that's an x and a y. It's an ordered pair. And g prime of -3 is 7. That's a slope. Use the tangent line of g of x at x equals -3 to approximate g of -2.9. So to do this, you first have to write the equation of the tangent
Isn't that a
line.
pretty simple question?
Well, there's a lot of ways to answer that. Maybe relative to everything else, sure. I mean, but when you
Wouldn't it
know,
just be 7 times x plus 3 in parentheses plus 2?
how did you come up with the equation? 7 times x plus 3.
Plus 2.
So this is the equation of the tangent line, yes. Okay, and then you can evaluate it at -2.9. So you'd have 7 minus 2.9 plus 3 plus 2, 0.1, so it's 0.7, 2.7.
Okay. And then 4.7.
Yeah, there's two approaches to 4.7. One is, so after you, sorry, first, when you evaluate this 5 to the 4th minus 625 over 5 squared minus 25, you get 0 over 0, which is indeterminate form. Two approaches here. You could use L'Hopital's rule, which is probably what most students would do,
Can't you simplify?
or you can simplify first. Yeah,
X squared minus 25 and x squared plus 25.
right. And that's probably faster because it cancels out, but it depends if you see that. So, some students might not see that. So you get the limit as x approaches 5 of x squared plus 25, which is 50.
Okay.
The next page refers to something else.
It's a little different. We can just do some of it. Or if you
Oh,
want to
oh,
skip
oh,
down to the very bottom and just do the lowest be tallest rules, or we
oh, I
can
see.
do
Oh, I see. It just refers to the tables on,
basically page, like the 2 pages following. It's like a circuit where you start on question 1, and like the first question will lead you to the next question.
okay, it's up to you. We can, whatever you want.
Sure, we can just do the circuit. So we'll start on the question label number 1.
Okay. All right. So grab this here. All right. So K prime of 1, K prime of X is F prime of X plus G prime of X. So K prime of 1 means to find F prime of 1 plus G prime of 1. So it looks like, scroll down for that.
And yeah, there's a
Yep. So can you tell me, I got it up on the other screen. Can you tell me F prime of 1?
-8.
-8, good. And then G prime of 1 is?
Wait. K G prime of 1
Yes.
would be 3.
Okay, so that's -5. So what does that mean here? Does that mean we have to go?
So then there's one at the bottom left.
So, but lower, yeah, the lower right there, the one that where the answer is -5.
Yeah.
Okay. All right. So this one says d dx, the derivative of 1/2 f of x plus 2 g of x, and then you evaluated it at, I guess that's a 2. I don't think it's -2, but so your d dx here is 1/2 f prime of x plus 2 g prime of x evaluated at 2. So 1/2 f prime of 2 plus 2 g prime of 2. So you're going back to that table. What's f prime of 2?
Sorry, let me scroll down. F prime of 2 is -12.
Good. And 1/2 of that. G prime of 2.
Wait, let me just write this down.
Sure.
G prime of 2 equals 5.
Good. So it's
Negative
-6 plus 10. Sorry.
which equals 4.
All right. So where do we go? Looks like it's
Second
on.
page, middle.
Yeah. So now we're doing product rule. All right. So your product rule here is f of x g prime of x plus f prime of x g of x, f of 1 g prime of 1, f prime of 1 g of 1. So you got to know your product rule. This is kind of a nice practice, but you can get more like the problems we were doing the other day with derivatives. These are
Very
kind of,
simple.
these are very simple. Yeah. They
Okay,
build
so
up to the big ones. So
f
this is
of 1 equals 3. G prime of 1 equals also 3. F prime of 1 equals -8. And then G of 1 equals 2.
good.
So it was 9 minus 16, which equals -7.
Okay, very good.
And then it's on the second page, bottom middle right.
Yep. All right. So I can almost tell the next one's going to be after quotient rule will be a chain rule. So this is your chain rule. Now notice your teacher switched G and F. That's where sometimes it's better to go bottom and top because normally the rules remembered like this, but your F and G are different positions. So this is f of x g prime of x minus g of x, f prime of x over f of x squared. And you're evaluating it at 2.
Okay. So g prime of 2 equals 5. F of 2 equals -6. G of 2 equals -1/2. And f prime of 2 equals -12. And then f of 2 equals -6. That's -30 minus 6. For a positive. Would it be -1?
Appears to be -1. Yeah.
Okay, so it's the first page, bottom.
As predicted, chain rule. It is good. I mean, it would be good the first time you saw derivatives. I got another student taking calculus. I actually probably use this with them. So thank you. This is 2x g of x, although I don't know why it's written this way.
So what
So
is 10 times g of 10?
but you got to take the derivative first. So actually I take that. Like, I think it's better. Like, this is how I see it. I believe it's written this way, which is, I'm sorry, it's not chain rule, it's product rule. Even though, because I was thinking there'd be an F here. So this is product rule.
Okay.
So I was wrong. So derivative first, keep the second.
Times g.
Okay, and then you're going to go back to the
Okay.
table and
G of 5 equals 8. That's 2 times 8 plus 10 times g prime of 5, which equals -5/2.
okay, so that's 16 plus -25, so -9.
Okay. And
Now,
that's on the second page.
is that, sorry, is that somewhere else?
Yeah, it's on the second page in the middle. Do you see
Oh
it?
yeah, there it is. Thank you. I got worried. I thought, well, wow, where'd the mistake go? All right. All right, so the derivative here, derivative of x cubed is 3x squared minus 2g prime of x. So power rule, constant times a function. So we got 3 times 1 squared. K prime of 1. 3 times 1 squared minus 2 times g prime of 1. Please check this, just because I know that I'm probably getting a grade on this. So let's make sure we're in unison on your results here.
And then k prime of 1 equals 3 minus. Yeah, I got -3 too.
All right. So does this just keep going till you hit them all? I mean, or does it, what
Yeah,
is it?
basically you hit them, you go to all of them.
All right.
It's just,
So why wouldn't you just do them in order? Oh, I guess maybe you're graded on that.
I don't know.
Okay. Sorry, I shouldn't ask questions like that. We'll just keep going here. Yeah. So K of 1. This has the appearance of quotient rule, but if you rewrite it, it's 1/9 h of x plus 6/9 times x, which is really 2/3 x. So the derivative is less complicated than it appears. So your k prime of x,
Mhm.
1/9 h prime of x plus 2/3. Okay, so I think we're finally using the other page now, or not the other page, the graph.
Okay. Okay.
So let me make some comments on this. What I like to do is get the slope of each one in each of these pieces and write it down so that I'm not having to recalculate it each time. So this h of x here is down 3, right 1, so it's -3 in that part. And then over here, you got rise of 2, run of 1, so 2/3. And then do the same thing for j. So slope of rise of 2, run of 1, so this is a slope of 2. And then in this other section, it's a minus, looks like it's -1/3 for that.
But aren't we only using the blue line?
We're probably going to use them all though at some point, and you
Oh.
don't want to have to recalculate. Like if this were on an AP, I would say no, but because you're doing some sort of circuit thing, you'll want to redo it. So in this problem, you only want h prime at 1, which is the blue one at 1 -3. So this is 1/9 times -3 plus 2/3. So -1/3 plus 2/3 is 1/3.
Okay. And that's the top, the first page top.
Okay.
Right.
All right. So let me snip that in. All right. So again, maybe simple a couple. You could simplify the derivative here though is 4 times f prime of x plus j prime of x. So we want f prime of 1 plus j prime of 1, and then multiply it by 4.
Mhm.
All right, so go to, let's see here, f prime of 1. We've been doing a bunch of those. That's -8. J prime of 1 is going back to, it's the red here. So notice how convenient it is if you've pre-calculated the slope, which is 2 times 4.
-24.
Yeah, -24.
And then that's on the second page.
All right. So we want m prime of 5. That's 7 times h prime of 5 minus 5 times f prime of 5. We've got these values. Let's see here. F prime of 5, been doing that a bunch. That's 1/3. Ooh, doesn't work out great. And then h prime of 5, you got to go back to the graph there, and you're looking at the blue here at 5. 1, 2, 3, 4, 5. So along here is the 2/3 along this section. So 7 times 2/3 minus 5/3 actually works out pretty nicely. What do you got here for this?
Just 9/3, which equals
Yeah,
3.
perfect. Yeah. All right, so we're on here. Feels like we're more than halfway through this
Yeah, 'cause
circuit.
it's 16 blocks, so
I mean,
or more.
up to you. Up to you if you want us to keep going or switch to L'Hopital's rule for the last little bit
Let's
here.
just do this last question.
Okay. So
Wait, do we have 10 minutes left or
yeah,
20?
we've got 10 minutes left. 11
Okay, let's just
minutes.
do the number 10, I guess, because we're already here, and then we'll switch to lost
Sure. So product rule, derivative of the first times the second plus keep the first derivative of the second. Evaluated at 1, so h prime of 1, j of 1, h of 1, j prime of 1. So we got to go back to our table. Nope, these are the lines,
Graph.
the graph, yeah. All right. So it looks like here h prime of 1 is -3. J of 1 is 2. Oh, this is completely wrong. So J of 1, you're evaluating the graph at 1. So that looks like it is 3. So just to be clear, that J of 1 is, here's 1, go up and hit the graph of J, and I put it in the wrong spot. That's 2. Wow, really messed that up. 2. H of 1 is 3. J prime of 1 is the slope, which looks like it's -3. All right, so please double check it. This one, maybe that's, I mean, your check is to see if it actually is in that list there.
It's not.
Yeah, so I made a mistake here. So h prime of x, j of x, h of x, j prime of x, and this is 1 for sure. It's kind of grainy.
Yeah, I would
Okay.
assume.
All right, h prime of 1. So we're looking at the slope here. That's -3. -3. What did I put? -3. J of 1 is to evaluate at 1. So here's 1. J of 1 is 2. That looks okay. H of 1. H of 1 is 3. Okay. J prime of 1, the derivative of the other one at 1, is 2. Huh. What do you see? Because I'm not seeing it right now.
Yeah.
H prime of 1 is, did I get the slope right? Down 3, right 1. That's right. J of 1 is the red, which is 2. H of 1 is 3. J prime of 1 is, okay, so I believe the mistake is J prime of 1 is +2. That's the mistake there. So this ends up being 0. And maybe there's a 0 on there. Yeah, there is. So I guess you can keep going on that. All right. We kind of got into L'Hopital's rule last time. We'll just go through these one at a time, or do you have specific ones you want us to do?
I haven't even looked through them, to be completely honest with you.
Okay.
You
So
can do the first one and just
You always try zero, and you're looking for indeterminate form. It lists the indeterminate forms at the top of that. So this is sine of 0 over sine of 0, which is 0 over 0. So that's indeterminate form. Take the derivative of sine is cosine. So cosine 2x, chain rule times 2. Cosine 5x times 5. If this were a formal test, you want to rewrite the limit notation. You'll probably see this on the multiple choice section, so you don't have to be that formal. This one now works because the cosine of 0 is 1. So you evaluate again here, and hopefully it works out better. Cosine of 0 times 2, cosine of 0 times 5, and you get 2/5.
Okay.
Any questions on that?
Yeah, that makes sense.
Okay. All right, number 2, kind of same deal. You want to try 0, see what happens. The bottom is 0. That's not great, but means we were looking for 0 on the top. So 0 plus 1, that square root of 1 is 1, minus 1 is 0, minus 0 over 2. So you do get that indeterminate form. You have to be able to take a derivative. Why don't you try or give me the derivative of the top, please? How are you doing on this one?
I'm still working. Do we just take the double derivative of it?
Just the first derivative for now. Should be like 1
I
over
did
2.
the first derivative and it's still 0 over 0.
That's right. Yeah, you have to evaluate it one more time. So you take yet another derivative, and the bottom becomes 10, which is, that's good. The derivative of 1/2 goes away, so you're really looking at, and sometimes it's worth rewriting, 1/2 x plus 1 to the minus 1/2. So your derivative is minus 1/4 x plus 1 to the minus 3/2. And then you can evaluate at 0. The nice thing is that 1 to any power, positive or negative, is 1. So that x plus 1 to the minus 3/2 just becomes 1. Minus 1/4 times 1 over 10. This becomes minus 1 over 40. Let me know when you get all this down.
Yeah, I got it.
All right,
Do
so
we
just
time for one more or?
yeah, but real quick, I just want to just remind you, the best way to write ddx of square root of x is 1 over 2 square root of x. I know it's x to the 1/2, but this will save you some time if you can write it in this form, 1 over 2 square root of x. Yeah, let's try number 3. This is another indeterminate form. So natural log of infinity, it's like, what's going on there? The graph of natural log goes to infinity. So that's why the numerator goes to infinity. 4 square root of x, the graph of that also goes to infinity. although it seems like it doesn't get there, but it does. So you do have infinity over infinity. You don't need to prove it on the multiple choice. Like you can just like justify it to yourself, but you do have to take a derivative. All right, so the first one's 1 over x. The second way, again, that's why I mentioned that one, it's 1 over 2 square root of x. For the square root of x, 4 divided by 2 becomes 2. So this bottom here is really 2 over the square root of x.
Wait, how's it 2 over the root of x? Oh, yeah, you're right. You're right.
Okay. Now, what you're allowed to do in L'Hopital's rule is simplify. And because if you start putting infinity in, you're going to get 1 over 0, which is 0, 2 over square root of 0, or square root of infinity, which is 0. You're going to get 0 over 0 again. And like the x is just going to propagate with its power. Same with this one here. So you really want to multiply the top and bottom by the reciprocal here. Square root of x over 2, square root of x over 2. And the nice thing is that you get some cancellations. You get limit x goes to infinity. Square root of x cancels with square root of x here cancels with this x, leaving you a square root of x in the bottom. So it's 1 over 2 square root of x like that. And then this does 1 over 2 square root of infinity does go to 1 over infinity or 0.
Okay.
All right, so we do have to stop here for tonight. Good job.